Hello, good afternoon, friends. So today is the second lecture for this PV training. So yesterday in the class we started the introductory section session for the PV Lit. In that we seen basic tabs like files, element, details, utility, and some settings here in the job specific configuration and then design constraint. Now we're going to see, and we may make one model here of vessel, and that horizontal vessel it is, and this is the left side dish head, the shell element, and this one is the dish head. So now today we're going to see how to add a nozzles in that. So nozzle, as you know, it is a main important component for this vessel. So let's add one nozzle here. Suppose this shell length here, we entered here 2500. So I need one nozzle of 6-inch size in the top shell in 90-degree position in the top. Okay, so we'll start with here in the detail tab. You will find a nozzle icon. So you need to click on that. First of all, you need to select the element where you want a nozzle. Suppose here now we given only one shell course, but in case there are multiple shell course, so you need to select that particular shell course, and then you need to click here in the details. First icon element is input, a nozzle input. So once you select once you click that one, so this tab will open. In that there are various options of nozzle attachment, like nozzle without reinforcement pad. This one is nozzle with reinforcement pad. This one is nozzle with set-on construction. If you know that set on means the nozzle neck will be welded on the above the cell. It will not go penetrate inside, means it's a above. And here with pad the same configuration. This one is leap type configuration, self-enforced leap construction. And here in the bottom this one is hub type self-enforced nozzle. So here there are six nozzle configurations are given. So for timing I will use the first one with nozzle with RF pad construction. This is the first one. And if suppose you have a 2-inch nozzle or 3-inch nozzle without RF pad, you can use this one option. So first we'll go with this. So suppose I have a nozzle number as N1, so we'll type here N1. Here by default its material came as 106 grade B. Suppose my material is, if I have to select, suppose my material is SA333 grade 6. So I need to type SA is already there. So 333, and I will put suppose enter. So it will automatically give me all the materials. So in that in the list if I have to select, so I have to select suppose SA333 grade 6. So I will click this one time, and I will simply select a material directly from here. So that in this section we can see the material naming, its temperature, and its stresses allowable. These stresses are allowable stresses here listed. So we can see the properties and the temperature and stress value, allowable stress value. You have to select OK, select it, make it OK. And as you know, this is impact tested temperature for LTCS material. So we'll keep OK. And if this is a standard pipe, so 6-inch, if my pipe is schedule 80, just now I am randomly selecting the material. And here the pipe we will design always on OD basis. So we'll keep this OD. Okay. And in the bottom, if I have to give the different distance, so suppose we need a distance from uh, tan line. All the dimensions mostly is given from tan line. So if I have to given from tan lines, I will write from the elevation. If I have to give from the weld seam, I have to give, I have to type here. So from tan line, if I have to enter the nozzle distance is 600 mm. I'll keep here 600 and I'll press enter. So it automatically selected 550 from the weld seam. It's talking, we are talking about these locations. Like my datum line is my point of reference point is from 10 line, and joint here it is after 50 mm. This we given 2 inch as a 50 mm as a SF straight face. Now here layout angle, as I said, it will be in the top, so it will be 0 degree. Then afterward, this nozzle we can see the result already here. It's A1, A2, A3, A4, A5. These are the available areas, and this is the AR is the required area. Our required area requirement is 5.812. So this is the required area, and now available area after calculating all this A1 to A5, we have 12.12. So there is enough margin available. So our nozzle is okay, passed. So mostly we are giving like a 2 inch of RF pad. Suppose I will give an RF pad OD as a 280, pad thickness I'll keep same as a shell thickness here. Weld leg OD if I will give suppose 5 mm only. Okay, and here it's a 10 mm nozzle fillet weld. It's automatically it selects here the flange material. It's selected 105. We can select the different types of flange types here, like weld neck, long weld neck, lap, slip-on, socket, threaded. There are various options are there. I will select a weld neck flanges, and if you are designing a manway, or if there is a blind, you can click this one. And if you want to perform UG44 calculation, you need to check here the derate the flange option is there. You can select this one, and here if I so to select, and if I will press OK, you can see the nozzle is already added. This is just to show how to add a nozzle. Actually, I didn't fill all the parts. Like once we given the schedule, it's automatically calculated its thickness. It's all values like weld I given here. So it calculated the weld required area and weld required thickness here. 10 mm is very high because our thickness is 8 mm only. So I'll keep it 8. It is very near to this one. Groove weld means shell thickness is 8 mm, so it cannot be more than that. So it's a 8 mm only here. So in this way we can provide the input. And here very important option is like projection projection of nozzles. So there are two ways to give projection in the nozzles. Suppose if you know the projection from the top, like from top of the vessel to the flange here, straight face. So you can provide directly HF here. Suppose my that dimension is 200 mm. I will write 200. So I am getting here HO. This pipe length from the top face is 111.1. So directly I can give this value and I can press OK, and I can calculate the overall weight also, overriding weight. So in this way we can calculate the flange. We can give the flange inputs, and if you have a flange like nozzle projection from the center of vessel, many companies, most of the it is preferred way to give nozzle projection from the center. So you can directly give the projection from the center here in this tab. Directly you can enter the projection, calculated projection. So here it is inside diameter 1500, so 750 plus 200, it is 950. So I'll put 750 plus 200, 950, 750, yeah, 200, 950, and it will give 103.10. Here the small difference is just because of uh, this thickness of these plates. That's only. So if I will keep here 958, then it will give the exact same value what we provided in HF. So you can verify also in this way. So now I will keep only 950 as a projection, and I'll keep OK. It's give us the dimension, and in this way we can have a nozzle on the top with 200 mm projection. Suppose if you want to move this nozzle, or if you want to change the orientation of nozzle, you can simply change the layout angle from here to, suppose I want to move to 90 degree. So I can simply type the 90 and I will press the OK. It will shift it to the 90 degree. And there are various set here. The views are there. You can see the front view here. Many views you can explore it as so and all. This in this way you can find the 2D, 3D, here drawing view, and there are some latest updates, upgradation is over here. So now when I'm recording the video, 28 version is the latest release date is also given. So I'll move back this nozzle to 0 degree. Suppose I need to add a blind flange above this one. So just I will double click on that nozzle and I will add a blind flange here directly by clicking this option. I'll put the OK. The blind flange will get added. So in this way, whatever size of nozzle, you just need to select this one, and by selecting a proper configuration, proper material, you can add suppose here I want to change the material of flange. Here it is by default 105. So I have to browse the material, or if you want to see the properties of SA 105, you can click the properties. You will see all the properties what you selected, or, or it's available. If I have to change, so I need to browse the material here by clicking that triple dot. Then here it's a material in the search tab. If I have to select as SA 350, suppose my material is a 350 LF2 class 1. So yeah, we can move this one slightly so we can see. Let's say 350 LF2 class 1. This is the material. I selected. I just click one time and then select the material. You can see the properties, temperature, allowable stresses. Just select it. So material will get changed. Is okay, and your material is changed. So in this way, you can add a nozzle. Uh, in the starting, we seen the datum reference line. So we just will see that datum reference line setting also, so that it will be easy to know. It will be beneficial to know the how to set the datum, because it's also very important. So in the design constant tab, just click on the design constant tab. You will see here datum line setting in miscellaneous design data. Just click on the three dots, then you will find a datums here directly. So datum line is an optional reference point for the nozzle or some other vessels. Datum is taken from, if the first option is checked, it means datum is taken from bottom or left tangent or bottom of the vessel. If its vessel is vertical, then it will take from bottom left tangent. If it is horizontal, then left. Because it's in pivot, you need to design from left to right. But in case of heat exchangers, sometime the your bundle you will find from right to left. So in that case, there is a in heat exchanger option. There is an option to change the direction of bundle. So later on, when I will make um, a training video for heat exchangers, soon it will come. So in that, I will show you how to make heat exchanger also. So this is just an introductory, so that's why I'm just going to cover this one. In case if it is you want to uh, change the datum setting, you can just unselect this one, and you can also there is options are available here. You can select uh, left cell seam, or you can give the dimensions here directly 60 mm, 70 mm, whatever is your as per your drawing. So now we'll here if it is vertical, so bottom of cell from base of skirt. There are many options. Sometime when we are making columns, so dimensions are from base of skirts also, or maybe from the wheel seam, top seam. So we can change the datums accordingly here. Shifting of datum, sometimes we are shifting the datums on the shell from tangent maybe 1 feet, or in old drawings if you see, sometime datum shifting is also there, marking reference marking. So in that case also working line is shifted. So we can do here from datum line shifting option. So I will just now keep as by default from left hand line, and you can verify this one as here the dimensions are given. Like if you see, this one is 50 mm, 50 mm is shell joint, shell to deshead joint. So you can see here 50 mm, it means data, this reference line is here, and you can see here the 10 line is 2600. So 10 to 10 it is 2600. and our shell length is 2500. So 50 mm in the dish head, left dish head, 50 in the right dish head. So total is 2600. So it's correct. So in this way we can do the verification also. And I hope you understand how to add a nozzles. There are other things like suppose I have to add this nozzle, it is in radial position. If I have to add change this nozzle, suppose I will add one more nozzle in on hillside. If you see, this is radial nozzle. If we'll add one more nozzle, if I have to add one more nozzle, I can go, I will just simply click here, add one. I will write N2, and in this now I have a 4-inch nozzle. Suppose I have a 4-inch nozzle, same parameters, but I will just reduce the pad OD here to 200. 200 is less, then I will make 220, and distance I will keep before we taken 500, so now it will be 1200. Okay, I will keep the orientation angle the same. Instead of radial, we will just simply select the offset, and offset like our inside diameter is 1500, so I will keep the 500 offset. Okay, we'll keep the 500 offset, and then we can select the projection from the bottom. It is 1000 I'm keeping the projection as 1000 so we'll have projection. This is too high, so I'll reduce it 900 Okay, and here also you can see project nozzle offset and dimension is given 500 and layout angle in the top, from top it is offset. So just we'll press OK, and then we can see a nozzle, offset nozzle is developed. So this is the way to making offset nozzle. So it's becoming very out, so I will just reduce, simply I will just here reduce to 400. So let's see. Okay, yeah, now it is shifted in this way. So if suppose if I need a nozzle, same nozzle in 90°, so you can just simply have here, instead of 0°, you can change it to 90° in the bottom. From 90° it will go 400 offset. Okay, so the angles here, you can see its layout angle will automatically get calculated if you enter in this dialog pad. We can open from the layout, go here and type the orientation and the offset angle and press the OK. Just calculate here the, so you can get the weight and press the OK. So now in this way, it is from the center, it is 400 offset to down. So in this way you can make a offset nozzle as well. So I hope it is very clear. And I don't need a blind flange, so I can remove a blind flange here. And one of the important thing is that nozzle loading. We have to add nozzle loading many times, means most of time when we are designing. So nozzle loading we can add from the second tab here, local load analysis, using WRC 107 297 and annexer G here. So just here in the, instead of here drop down you will open. So for this shell to nozzle joint configuration, we can use a WRC 297 here. If you have the loads provided by the company or your data sheet, you can manually enter the loads, or there in PV lead there is an option that you can directly select API 660 metric loads or as English loads. So it will directly come. But PV lead by default has load is reduced loads, means like it's only 40% here, 40% or 30%, 40% loads are there in API. So sometime, maybe after some time I will just teach you how to change the loads in the PV leads. There is a shortcut method for local load, and just table values we can directly select. So just by entering here a number of low load values and by clicking the OK, we can see here the calculation how it's doing, like vessel at the nozzle head, vessel at the pad edge, in the nozzle at vessel. theoretical loads. It's all calculated. You can see the margins available, like it is less than 1, so it's okay, and it's all passed results you can see here. You can press OK. So in this is the sign of nozzle load is applied. So we can say that the nozzle load is applied here. It's the same way if I have to apply a load here in for nozzle N1, I will just go here, click the local stress analysis, click here to 297. I can select this one tab. I will choose API 660. You can manually type also as per your project specification. We see it's okay for this, but these loads are reduced load in PV lead. By default, loads are reduced load as API as per API table. But manually, instead of doing manually, there are other option also. I will show you that option in some other class. How to change that the PV lead loadings in API table directly instead of typing manually. Okay, so in this way you can add a nozzle, and suppose uh, this is the way. Suppose I have to see the sectional view of this drum. So there is an option here in the right side. This is the option, insert cutting plane. You just click on the insert cutting plane and insert, it will get cut. So in this way you can move left and right, so to see the cut section. And moving left to right, you can increase the length of cut, and you can see inside. When you're working with column or heat exchanger, this option is very useful to see how the tubes are looking, or how the baffles arrangements is, or how the internals in the pivot columns. So this option is very useful. So by clicking on the same icon, it will unchecked. So in this way, seen the how to add the nozzles on the PV lid. In the next session, maybe we'll see how to add the saddle support in this same model. And maybe on the another next session, we will see how to add the platform in this horizontal vessel. After that, we will start with some real problems, like with the drawing, or maybe from data sheet we will make a model from scratch. So I hope you will like that videos. So please do like, support, share these videos. Thank you. Bye bye.